Do we have questions from the audience? Okay, start with questions, please. I think this has been or a session that has been put together in interesting ways. I would like to ask you a Rita question where I think that you guys all meet on some higher level. Selmer initially presented the point that basically address shortcomings in many of the approaches that currently exist in AI, which are very often probabilistic and rather dumb and do not put sharp constraints as logic does on thinking. And you are presenting a neural system, YouTube. And I would like to ask you what ways you see, if possible, to combine those approaches, or if you think that they are mutually exclusive. If they have to combine, because this is by extension of a logic-based approach towards a distributed approach, or the other way around, by getting the neural systems to become more logical, to be able to emulate or learn logic, or whether to do the hybrid approach that does both things. Who wants to start?
Well, it's true to form because it's complex, and you like that. Logic really doesn't fail to handle probability. I just want to make there's a subfield in logic called probabilistic or probability logic. The neural case that you're asking about is very different. I doubt there's much of a connection there because most people are working top down. So I'm just going to answer honestly. I don't see much. I know Rick Ranger showed a slide where he actually had a first order formula with one quantifier, and then later on in his slides he said, "See, I've got generality, I've got formal generality, but one little formula with one quantifier doesn't make formal generality." So I think they're not. I think they're incommensurate personally. Yeah. I don't think this one works. If you want to go to symptoms. Oh, that might be a very good idea. That's binary logic too.
My point of view, maybe some module can be integrated because my part was like recognizing sequences and but information coming from the bottom. Actually, or what I use was not state of the art at all. So maybe better perceptual module, neural network, or any kind of other recognizer at low level can work with my model. I'm not sure if those works can work together. I have to read their paper first.
All right, I like to be honest in all things if I can, and my honest answer is I don't have a clue. I'm sorry, I don't know enough, unfortunately, about what you do.
That makes two of us. We're very compatible.
I would have to say I need to do more reading, and I will definitely do more reading, and I'd get back to you, but I probably don't really need that. If you want, I can. If anyone wants me to get back to them, I'm more than willing. But yeah, I can't answer. It's beyond my current level of knowledge.
Yasha, you want to answer yourself, maybe?
I think we have enough questions from the audience.
But rest assured, he actually has an answer.
Yeah, I wanted to just comment, which will turn into a question on some of the things that Selmer mentioned. I mean, your first examples of novelty questions actually seem to be things that, a system like, we have an OpenCog now with a rule-based parser and then a logic engine can handle okay. Because, the link parser assumes if something acts like a noun, it is a noun. It will tag those things as nouns. You get concept nodes in OpenCog for nouns like blork or foo or bar or whatever. And then the logic relations will be made just as if it was an ordinary word. So I don't see those ideas as challenging for our system or for a host of other systems, because most language parsers will identify the part of speech of a word and make a concept for it. I mean, in terms of the relation between logic-based...
Could I just
sure.
respond to the first point?
Sure.
You know, the proof is in the pudding. So you bring me your system, and I'm giving it this problem, which is a variant of what I put up there. There is something, period. There is an X such that if X is a bit pica, then everything is a bit pica, period. Is the second sentence true? And if your system can answer correctly and give a proof, I want to invest in your system.
Well, right now the system could maybe do the examples you gave, but not that one. The examples you gave were different because the novelty was just...
they're propositional, right?
Well, the novelty was just that they were made up words. But my point is that dealing with made up words is not hard. What you just described there was the second sentence. I mean, this is... The system has to have a model of discourse and refer to the model of discourse.
I want to see it work on the ones that are in the slides. The point's well taken. It's unfair for me to change it, so I'd like to see it.
Yeah, I mean, I think that there's nothing that's not doable within our model or, say, fluid construction grammar or a bunch of other similar things in your more difficult example as well, but that is beyond what our system is doing now. To comment on the follow-up point that was just made, I mean, how would a logic-based QA system interface with something more like Watson, which does logistic regression or conventional search engine type stuff? I mean, one way to do that is to use this search engine type stuff to dig up possibilities that will then guide a logic engine to answer questions. Because a logic engine can easily get lost in combinatorial explosions. So if the search engine tells it where to look, the logic engine can then look in that direction and have a much faster time in finding an answer, which is then defensible with justification. So I think there's plenty of avenue for interfacing of those two kinds of systems in a QA system. Although I don't think IBM happens to be going in that particular direction now.
Well, I think you're right, and actually IBM is doing that. It's really cognitive computing now, not specifically what Watson's doing. However, I think in the case of Watson, and we talk about this in the paper that I alluded to, Naveen and I would have been much happier if it had been an explicitly logic-based system. I think the performance would have been...
That's a surprise.
I don't think the performance would have been... I don't think it would have been... Personally, I don't think it would have been any different because the structured knowledge wasn't that expressive. So you would have been at the level of decidability. These are description logic level formulas with metadata. It wouldn't have been.
Well, it's interesting that they're going in that direction.
Yeah.
And it's clear that we have ideas on how to do this because it's basically our approach on combining those things. I thought when we had the chance to have somebody who's a proponent of logic-based systems, basically, and two neural guys, if we asked them, that we could see some blood, but we don't. No blood. Okay. Glenn, did you have a question? No, okay. I have one more question for you. You were suggesting to use emotion as feedback signals to control the robot. And as an example, you gave anger. In which sense is this anger what you're using? Because, I mean, anger is different from regret or negative reward signal or grief and so on. Anger is also associated with increased arousal typically, with increased readiness or propensity for action, with less resolution for thoughts, and most importantly, functionally, in anger, you have an obstacle that is between you and your goal, and you have a tendency for sanctioning behavior towards that obstacle. And in your case, I just saw a negative reward signal. Why would you say that this is emotions?
Well, I used a simple model of emotion because I needed something real quick to influence my system, and anger, in my case, was relevant because it's not a reward, but if the robot can recognize the ongoing sequence and in the prediction, he sees that the next event has a negative emotion. The robot will try to a different approach to his problem before going into the same anger problem. I don't know if I answer all the questions.
I think the basic question was, why is that formula called anger instead of just called negative reinforcement?
Yeah. Well, it could have been called negative emotion and positive emotion as well.
Okay, because there's a lot of other negative emotions besides anger, at least for most of us.
Yeah, I know. That's what I also think that we need a more complex artificial emotion module but the question also
I have that for you if you want it. It's based on 22 primitive emotions represented as fluents in the event calculus. You're not my 22 emotions, but they're in the literature.
Do you only have 22 emotions, Selmer?
We need to expand it because it doesn't cover vengeance. And of course, I'm serious. You can't derive vengeance as we formalize it from the 22. Okay, it maybe sounds absurd, but it's true. Sorry. Do you want it, or I can email it to you?
I could. And also, what I wanted to say is we don't know exactly how does the emotion will impact the memory. So even if it's a different type of emotion, how does it? What's the equation? How does it influence the memory exactly? It's not something we know exactly. So I just pick negative emotion. Have been anything else.
I think it's very interesting that you mentioned calculus-based approach to emotions. Stacy has given you good reviews over the literature on artificial emotion approaches. And right now there are a number of schools and modeling approaches, so also systems that emerge and so on. But I think it's pretty important to model when we talk about emotions, to model them functionally as emotions, not to just pick an arbitrary reward signal, just label this an emotion, because in a similar way, the predicate is not identical to the fault, or camera image is not identical to perception. And when we as AI researchers work on these things, I think also the conceptual analysis that we are doing is part of our job. But thank you. I think it's a very interesting approach. And I would like to thank the panelists for their contributions and for the interesting talks in this nice session.
I would just like to say before you stop, the fact that anybody is here after the length of this day, I'm really grateful that you all said that. I know it's really amazing fortitude here. So, yeah, it's late. Thank you.